Section 10.5, Math 96. In this section, you start with like terms. What are like terms? When you have two terms that are identical, they call them like terms. Like here, let's say I have 8 apple and I add another 2 apple. So the variable parts both are equal. So then I have 10A2. Or if I have 5x2 minus 3x2, the variable parts are, these two are identicals. In that case, you subtract and then you have 2x2. I have 7xy plus 2xy. Again, variable parts are identical, so that would be 9xy. But if you have 5x2y and you want to add that to 3xy2, you can't do that because these two are not like terms. See, the variable parts must be identical. And these two are not, so you cannot add. So now in this example here, 8 cubic radical y plus 5 cubic radical y is 13. And this one, there are 4 terms. These two are like terms. They both are cubic root of x. So positive 9 minus 7, that would give you 2. Radical 2 and radical 2 are like terms. You have 2 radical 2 and 8 radical 2, that give you 10 radical 2. So you collect the like terms. Like on these 4 terms, these two are like terms and these two are like terms. Now, when you have 2 radicals, you want to simplify that. Simplify radical means you try to get some numbers out of the radical, like 50, you could break 50. 50 is 2 times 25. 18 is 2 times 9. Then I write 25 at 5 to power of 2, and 9 as 3 to power of 2. This 5, the power and the root are the same. So you could release the 5 from the radical. When 5 comes out of the radical, there is already a 5 here. So then you multiply these two, okay? So it would be 5 and 5 is 25. And then here, 3 comes out. 3 times 7 is 25. It should be 3 here. So when the 5 comes out, it's multiplied by 3. Now here on this one, if you want to break a number, the best way is to take the number and always divide by 2 first. If 2 doesn't go to 270, then you could try 3. And you could always use your calculator. Like I take 270, I divide by 2. I see a decimal number. And then I try 3. 270 divided by 3, when I use my calculator, I see 90. Again, divided by 3, 30 divided by 3 is 10. Now 10 is not divisible by 3 anymore, but it is divisible by 2. 5, 5. So you see here, I have 3 times 3 times 3 times 2 times 5, or 3 times 3 times 3 times 10. 3 to power of 3 times 10. And here, x to power of 4, since the root is 3, we write x4 as x3 and x1. You don't have to put that one. So you always look at the root, what number you have on the root, and try to have this number multiple of that. So if I have x4, x4 is what? Means this, x times x times x times x. Or x3 times x. So when you write it like that, then because this x, 3 and 3 are equal, this x is released from the radical. See? And 10x remain. And here, 3 to power of 3. 3 comes out of the radical, is like that. You could also write this as 270 times 10. That's another way to do it. When you write it as 270 is 27 times 10, then 27 is 3 cubed times 10. You could also do it this way and write that number here. Now, these two are like terms. Look, cubic root of that and cubic root of this. So it would be 3 minus x in the parentheses, cubic root of 10x. Then it goes to multiplications. When you multiply these two, you start with one of the parentheses. You take the 2 and multiply by 5. 2 times 5 is 10. What is 2 times minus 3 radical 3? It's minus 6 radical 3. See, when you have a number, this is an example. When you have a number and you want to multiply that by radical, let's say you want to distribute this number into the parentheses. 2 times radical 3 is just be 2 radical 3. And then 2 times 4 is plus 8. But let's say you have 5 radical 2, and you want to multiply that by 7 radical 3. Numbers that are not radical, you could always multiply those separately. So 5 times 7 is 35. And then you could multiply the radicals. Radical 2 times radical 3 is radical 6. So radical A times radical B, you could combine into one radical and write it as AB. As long as the roots are the same, remember, the both are 2 here. If I have cubic root of A and times cubic root of B, then that would be cubic root of AB. So you could combine 2 radicals as long as they both have the same roots. The roots are supposed to be equal. Okay? Like in this one, I have 7 plus radical 2 to power of 2. What you could do here, you could assume that this is 7 plus radical 2 times 7 plus radical 2, the same thing. And then you go ahead and multiply. See, 7 times 7 is 49. What is 7 times radical 2? 7 times radical 2 is just 7 radical 2. What is radical 2 times 7? The same thing, is 7 radical 2. What is radical 2 times radical 2? See, radical 2 times radical 2, I'll show you. Radical 2 times radical 2 is, under the radical is 4, right? Or is just 2 to power of 2, or 2. So when you take a radical multiple by itself, the radical is always moved. Like if I take radical, let's say A times radical A, the result is just A. Because why? Because you have radical A to power of 2. 2 and 2 cancel, A is released, and there is nothing under the radical. Number 6 is very similar. Now, what is rationalizing mean? Rationalizing means that, let's say I have a fractions like this. When we ask you to rationalize the denominator, means I don't want to have any radical at the denominator. If you want to move the radical from the denominator, you multiply this by new fraction, which is radical 3 over radical 3, which is like 1. But then radical 3 times radical 3 is what? 3. Remember, if you take a radical and multiply by itself, I do it again so you could see it, is 3. And then the top is 2 radical 3. See, changing this fraction from 2 over radical 3 to 2 radical 3 over 3, they call it rationalizing denominator. Means it doesn't matter if you have a radical at the numerator. You just don't want the radical at the denominator. So when we say rationalize denominator, means try to get rid of radical at denominator. Now, what if you have a minus radical 7? In that case, we have a rule which is if you take a minus b and multiply that by a plus b, they say conjugate. We had that in the factory. The outcome is a2 minus b2. Both must be equal with the opposite sign. So if I have 8 minus radical 7 and I want to remove the radical, you have to multiply by 8 plus radical 7 or over 8 plus radical 7. Why? Because these two, 8 times 8 is 64 minus, what is radical 7 times radical 7? 7. And the top is just 2 times that. See, you don't have radical at the denominator based on this property which we had in the factory. They call it rationalizing the denominator. See, like here, I want to rationalize this. So you multiply by 5 plus radical 7. Doing that, 5 times 5 is 25. Radical 7 times radical 7 is 7. And the top is like that you multiply. See, you don't have radical at the denominator. So there are two kinds of rationalizing. One is you just have one radical, so you multiply by itself, or you have something like this, look. Radical 5 minus 2. It's not just one radical that you multiply by itself, it's the difference. So in a case like this, to rationalize, you multiply this by what? Radical 5 plus 2 and radical 5 plus 2. Doing that, then at the denominator, you have just 5 minus 4, see? And the top is 3 times radical 5 plus 2. So you have two types of rationalizing. One is you just have one single radical, always multiply by itself. Or you have the difference or sum of two numbers and the radical. Then you have to do that conjugate formula. See, I multiply by radical 7 plus radical 11. In that case, it's 7 minus 7. Now, we also ask you to rationalize the numerator. This time, you do the same thing, you try to remove the radical from the numerator, from here. So see, radical 13 plus 3, we multiply by radical 13 minus 3. All right? So radical 13 times radical 13 is 13. And what is positive 3 times minus 3? Minus 9. See, you don't have radical at the denominator anymore. It's okay to have a denominator, but not at the numerator. I'm sorry. You want to rationalize at the numerator. Same thing. So when you see a problem and you say rational numerator means work with this. So you put opposite of this one here. And so on. Okay? The last one is also like that. You want to rationalize this one, the numerator.